Hello my dear students, welcome back to our topic that is a real number, and in the previous class already we have discussed about the Euclid's division lemma. Okay, and today we discuss about the fundamental theorem of arithmetic. Okay, so what is the fundamental theorem of arithmetic? So you just read here. I have written that every composite number can be expressed as the product of prime numbers, and this factorization is unique apart from the order in which the prime factor occur. So that means in generally the fundamental theorem of arithmetic states that every composite number can be expressed into the product of prime number factors. Okay, only prime number factors. So first going to that, now I would like to tell you that what is the prime number, what is the composite number. So prime number means, what is the prime number? If you will tell, it's a very basic thing. The prime number means it has only one, and that number itself is the factor. One and number itself. Suppose I will tell that 2. So 2 can be divided by 1 and 2, that is 1 and number itself. 3 can be divided by 1 and 2, that is 1 and 3 itself. Okay. 5 can be divided by 1 and 5 itself, so that only 2 factors is coming. So these are the prime numbers. So when I talk about the composite numbers, what is the composite numbers? Composite number means that means when a number will be can be divided more than 2 factors. That means more than 1 and number itself. If there will be more than 2 factors, suppose I will tell 4. 4 can be divided by 1, can be divided by 2, can be divided by 4. So 3 factors. Okay, so 4 can be divided by 1, 2, 4. Okay, so that means it can be divided more than 2 factors. Okay, so that's why it is called as what? It is the composite number, and it is the prime number. Okay, so now he is telling that this composite number can be expressed as the product of prime numbers, Now you see that we will come to our point that how we do the factorization so that it will come that the composite number can be expressed as the product of prime numbers. Okay, so now you come. Then from the beginning I will tell that what is the composite number. The first composite number you see that is the 4. So now I will express this 4 as the product of prime numbers, product of prime factors. So when I do the factorization, all of you know that here 2 2s are 4. Okay, so that means 4 I can write as 2 into 2. So now see, this is the prime and this is the prime. So now I could write 4 as 2 prime factors. Suppose I will take 16. 16 also a composite number. So 2 8s are 2 4s are 2 2s are. So now 16 is equal to 2 into 2 into 2 into 2. Okay. So now that means now this 16 is the composite number, and I could express it as the product of prime factors. So that means these are here all 2, the 4, 2 is there. I have done multiplication, and these 2 all are the prime numbers. Okay. Similarly, we will take another example here, that is 20. 20 also a composite number. Okay. So now 20, when I will do the factorization to 20, it will come 2 10s are 2 5s are. So that means 2 into 2 into 5. So that means you see 2 is the prime number. Here also 2 is the prime number, and here 5 also prime number. Okay, so that means this 20 I could express in the 3 prime factors, product of 3 prime factors. Here 2 is prime and 5 is prime. So now all of you clear that you take any composite number and you factorize it, its factor will come in prime numbers, and when we will multiply it, the number will be come. Okay, so now we clear about this. So now I will solve a question. Okay, so now it's your NCERT book example 5. Okay, so that means consider the number 4 to the power n. Example 5, NCERT. Okay, so that means consider the number 4 to the power n. Consider the number 4 to the power n. Consider number 4 to the power n, where n is a natural number. Where n is a natural number. Where n is a natural number. Okay, check whether there is any value of n. Okay, check whether there is any value of n. Okay, there is any value of n. So for which 4 to the power n, for which 4 to the power n ends with 0. Ends with 0. So that means now we'll solve this. So now my question is that the number 4 to the power n, the number is 4 to the power n, where n is a natural number. You know, all of know that is what is a natural number. N, it is denoted by capital N, and the natural number starts from 1 to, okay, of infinite. So this is a natural number. Okay, so that means n is a natural number. Check whether there is any value of n. Okay, if that means he is asking us that if there is exist any value of n, okay, for which 4 to the power n ends with 0. So that means, is there any value of n exists for which 4 to the power n will ends with 0? That means when I will find the product of 4 to the power n, when I find the value of the 4 to the power n, so it will come 280 or 180 or 580 or 270, whatever. That means the ends with 0. Okay, it will ends with 0. So now I will come to that point. So that means 4 to the power n. 4 to the power n, you see. So 4, it is the base, so 4 exponent is the n. And 4 I can write, that is 2 to the power 2. I can write 2 to the power 2. And this whole to the power n. Okay, so that means 2 to the power 2 whole to the power n, that is equal to 2 to the power 2 into n, that equal to 2 to the power 2n. Sorry, 2 to the power 2n. So that means here I can write 4 as 2 to the power 2n. I can write 4 to the power n is equal to 2 to the power 2n. Okay, so now you see 2 to the power 2n. 2 to the power 2n. So that means you take n equal to 1. For n equal to 1, it will be 2 to the power 2 into 1, that is 2 square, that is 2 into 2. For n equal to 2, that is 2 to the power 2 into 2, that equal to 2 to the power 4, that equal to, okay. For n equal to 3, 2 to the power 2 into 3, that equal to 2 into n, that is 2 into 3, 2 to the power 6, 1, 2, 3, 4, 5, 6. So now you observe here. Now it's very simple. Just you observe here that when the 2 square is 2 into 2 and 2 to the power 4, it is coming 2 multiplied 4 times. When 2 to the power 6, it is multiplied 6 times. So now you see when I will multiply, so 2 into 2, 4. 2 to the power 4, 2 to the 4, 2 to the 8, 2 to the 16. Okay, so that means when 2 will be multiplied again and again, so that it will never end with 0. That means the unit digit will never come 0. So that simply you can tell, so there is no value of n for which 4 to the power n ends with 0. For which 4 to the power n ends with 0. So now you come to our point. What will be the answer? So my answer will be, I am erasing this. Okay. So 4 to the power n is never ends with 0. Never ends with 0 for any value of n. For any value of n. Okay, for any value of n. So I hope you understood this example. So now we'll come to the decimal expansion of the rational number. Okay, decimal expansion, the rational number. So let's know that how to, that means decimal expansion of rational number. So let's know that rational number, suppose let x equal to p by q is a rational number. Is a rational number, okay, where q not equal to 0. So all of you know this, so it's not a new thing for you. Okay, you know is rational number is of the form p by q and q is not equal to 0. Q is not equal to 0. So when we do the representation, okay, decimal representation, then it will be like this. That suppose I will take 1 by 2, that it will be 0.5. Okay, that means how we do 1 divided by 2. 2, okay, 1 cannot be divisible by 2, so I will give point, that is 0, 2 5 is 10, so 0.5. Okay, so that means 2 by 5, so 2 will be divided by 5, okay, so that means 2 is not divisible by 5, so I will give a point here, now it is 20, so 5 4 is 20, so now my answer is 0.4. Okay, so my answer is 0.4. Okay, understood. So that means 0.4 means when we do the rational 4 by 10, because after decimal 1 point is there, 1 digit is there. So in one the right side there will be 1 0. There will be 1 0. So that it will be when cancel out 2 2 jar 2 5 that will be 2 by 5. Same number I got here. Okay, so that means in this is the division format, that how I will tell that what is the decimal expansion of the number. What is the decimal expansion of the number? So now in this chapter, in this number chapter, what we will do here, that without exact division, okay, that means this is the procedure to find out the decimal expansion. Okay, without doing this, how I will tell that it is the terminating or non-terminating recurring. Okay, so that means you see, it is the terminating. It is the terminating. Okay. So now I will tell that 1 by 7. 1 by 7. It is terminating. 1 by 7. 1 by 7 when I divide. 7. 1 is not divisible by 7. Give a point here. 10. 7 1 is 7. Then 3. Okay. So now you give 0. 37 4 is 28. Okay, 2 27 2 is 40 6. Just like this it will continue. Okay, so it will not end, it will not terminate. Okay, so that means what I will tell here, that how I will know this, that it is terminating and it is non-terminating recurring. Okay, non-terminating recurring, how I will know this? How I will know this, that it is terminating and it is non-terminating recurring. Okay, understood this? So that means now you see that if x equal to is of the form p by q and this q is of the form, the remainder, although you see that the remainder should be is of the form 2 to the power n into height to the power n. 2 to the power n into height to the power n. So that means you see that here, first I have taken 1 by 2. 1 by 2 you see that it is already 2 to the power n. I need 5 to the power n. So that means what I will do here, I will multiply 5 to the power 1, 5 to the power 1. Okay? I will multiply 5 to the power 1, 5 to the power 1. Yes, it is being converted into 2 to the power n and 5 to the power n. So it is terminated. Terminate. Okay? This is 2 to 2 by 5. This is also I can write 5 to the power 1 and into 2 to the power 1. Okay? Into 2 to the power 1. So this is also can be expressed 2 to the power n, 5 to the power n. Okay, you can tell any number, 2 square, whatever. Okay, so now this is also I can tell, yes, it is terminated. So now you see this 1 by 7. 1 by 7 when I will do, so it is 1 by 7. I can do any number, okay, but it is not of the form but 2 to the power n or into 5 to the power n. Okay, so that it is what? Non-terminating and recurring. Non-terminating and recurring. Okay, so now we will take some examples based upon this and we will solve this. So now you see this. So that means my main point is if the remainder, the denominator q can be expressed in the form of 2 to the power n and into 5 to the power n, then that is the terminating. If we cannot express in the form of 2 to the power n into 5 to the power n, then it is non-terminating. Okay, so now we will take some examples here. So now see 3 by 8. Example is 3 by 8. So it can be written as 3 by 8. I can write 2 to the power q. 8 I can write 2 to the power q. So what I will do here? I need 2 to the power n into 5 to the power n. 2 to the power n into 5 to the power n. So now 2 to the power n is here. So now what? 5 to the power n I will do the divide and multiply. Okay, so into 5 to the power n. Okay, so 5 cube, I have done the divide and I have done the multiplication. So now it will be what? 375 by 10 cube. 375 by 10 cube. So now it will be 0.375. Okay, 0.375. Normally you know that it is in the right side 1, 2, 3, 0. So from the right side I will count 1, 2, 3, then I will give the point. You know this and how to find the decimal. Okay, so now this is the example. Also we will take another example here, 13 by 125. Example 1, example 2. 13 by 125. So now you see we can do 13 by, it is what? 5 cube. 5 cube. So 5 to the power n. Q, that means the denominator I got that 5 to the power n. Now I want 2 to the power n. Okay, now I want 2 to the power n. That means 2 cube. Okay, so that means what I will do here? I will multiply 2 to the power cube in the numerator and divide 2 to the power cube in the denominator. Okay, so now what will be the product? What is the product? 10 by 10 to the power cube. 104 by 10 to the power cube. So it is also in the right side, that is 30. So from the right side 1, 2, 3, 401.0.104 terminating. Okay, so now what it concludes? That if the denominator, that is q, we can express in the form of 2 to the power n into 5 to the power n, then I can tell that its decimal expansion will be terminating. And if we cannot express in 2 to the power n into 5 to the power n, what I gave one example, that 1 by 7, then I can tell that it is non-terminating and recurring. Okay, non-terminating and recurring. So this is the trick to identify without the division to a rational number, that how to find out what is the recurring decimal, okay, repeating decimal, non-terminating repeating, and what is the terminating decimal. Thank you.